All right, so today's notes are on roots and radicals. Our content objective is to find nth roots, and our language objective is to use the correct terminology to describe roots. So the first thing I wanted to note is the key point that roots undo or cancel exponents. So we've spent a lot of time practicing exponents or using laws of exponents, and now we're going to learn how to cancel or undo them, and we'll see some connections and parallels between those things, or between exponents and roots. So first thing, just to be clear, if we had the square root of x squared, that ends up just being x. So the square root and the square undo each other. You're left with just x. Since it's even, you end up with plus or minus, since it's an even root. Because a negative times a negative would still give you a positive radicand. And then similarly, the cube root of y cubed would just give you y, because the cube root and the cube undo or cancel each other. They're inverse operations. They undo each other. So before we delve into some more complicated examples, I wanted to do some more straightforward ones together to see that they make sense. So if you want to try these on your own, I'd pause it. If you remember how to do these things, that'd be great. See what you remember. If not, I'm going to go over them now. So the cube root of -8, I know the cube root of 8 is 2. Since it's an odd root, I keep the negative sign. So the cube root of -8 would be -2, because -2 times -2 times -2 gives me -8. So for the next one, I have the square root of 0.04. Well, I know the square root of 4 is 2, but since this is a decimal, it's going to be 0.02. So just as a reminder, when you're multiplying fractions or decimals, you end up getting smaller values. So if I did 1/2 times 1/2, I get 1/4. So similarly, 0.2 times 0.2 is 0.04. So if I squared 0.2, I end up with a smaller number. So the square root of 0.04 is actually just 0.2. For the next one, I have the square root of -2 squared. So just to show you how I do that, -2 squared is +4. And when I square root that +4, I still end up with +2. So even though your intuition might be to just cancel those and say it's -2, you're not going to get a negative root, or you can't get a negative number from square rooting a negative. You'll still end up having plus or minus 2 as your answer. But if we're just focusing on the principal root, your answer would be 2. So it's not going to necessarily be -2. It would be 2 or plus or minus 2. I'll write plus or minus for now, but just in a second, we're going to talk about why it's not, normally I wouldn't write the plus minus here. We'll talk about why in just a second. The next one has the fourth root of -1. I don't know if anyone caught this, but that is not possible. Or another way of saying it is, it would be I think, sorry. But not possible because you can't take the root. It would just be I, but you can't take an even root of a negative number. So because it's an even root and a negative number, it's not possible with real numbers, which is what we will be focusing on during this unit. So we're focusing on real numbers, principal roots. So this would not be possible in this situation without imaginary values. The next one is the cube root of 27. Cube root of 27 is 3. So 3 times 3 times 3 is 27. I'm going to give you some tools. If you didn't know the cube roots of these values, I'm going to give you some tools that might be helpful later, but we'll talk about those in a minute. So the next key point I wanted to talk about, which kind of came up in some of those quick checks, is that an even index results in 2 possible roots because you have plus or minus. But the positive root is called the principal root, and that's the only one we're going to write when simplifying. So when we're doing this unit or this lesson, when we're simplifying, we only need to do the principal or positive root. So that's why I said right here, I'd normally just write 2, because when simplifying, you only need to write the principal root. When we are solving, we still need to do the plus or minus. So when you go back to solving quadratics, you take a square root, you need to do plus or minus, so you get both possible answers or both possible solutions. But for the sake of simplifying, we just need the principal or positive root. So you won't need to worry about the plus or minus every single time. An odd index results in only 1 possible root, and that keeps the sign of the radicand. And the radicand is the part under the square root. So a quick little vocab thing. If I had the nth root of a, this component is called the index. So the number here is called the index. The a is the radicand. And the symbol that shows that it's a root is called just the radical. So this is the radical, this is the index, this is the radicand. So that's some of the vocab we'll be referencing for the rest of this lesson. So I'm going to flip the page for the next example. So now we're going to get into some trickier territory. So this one, I want us to simplify the cube root of 54x to the fourth. So for this, there's two methods I'm going to show you, and you can choose which one makes more sense to you. You could do either or both. I'm just going to give you options, whatever makes the most sense. So method one is the more, I think, efficient one if you can do it well. So this can be more efficient if you can see what we're doing, but if it doesn't make sense to you, I'll give you a backup that works every time. So I'm taking the cube root of 54x to the fourth. First of all, 54 is not a perfect cube, so I'm not going to be able to take out a whole number when simplifying this. X to the fourth is not, you can't take a cube root of that quite so easily. So I'm going to show you how we can deal with that. So I'm going to try to break these, or break my radicand into components that I can take the cube root of. So I want to figure out perfect cubes that go into these numbers. So a perfect cube that goes into 54, I recognize as 27. So I have 27 times 2 would give me 54. I'm also going to try to break this into cubes. So x to the fourth, I know from my exponent rules that we've been practicing, is x to the third times x to the 1. So then I can rewrite this as 3 cubed times 2 times x cubed times x. So since I'm taking the cube root of these things, I'm going to take out the things that are perfect cubes. So I have 3 cubed and x cubed. So I'm going to take out the perfect cubes and I end up with 3x, because as I take them out of the radical, the exponent cancels. So I take out the 3, I take out the x, I have 3x. And then my radical with my index of 3 keeps the values that I could not take out. So 2 and x stay under the radical, and that is my simplified solution. So that's method one. You find perfect cubes that go into your radicand and then take them out of the radical. Method two is a little bit lengthier, but it takes less mental work in some cases. So 54x to the fourth, I'm going to make my prime factorization of 54. So if you remember factor trees, I'm going to do a factor tree of 54. So I know 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. And then x to the fourth would just be x times x times x times x. So I break it into my prime factorization. So I break it into the prime factorization. And then I circle, since my radicand is 3, I'm going to circle 3 of a kind. So every 3 of a kind I can circle, and then I can cross them out, write them in front of my radical, and I'm left with what is underneath. So I find the prime factorization, circle 3 of a kind, and this is since the index is, if the index were 4, I'd have to circle 4 of a kind, but since the index is 3, I'm circling 3 of a kind. Put those out front. So then I put one of each circled value in front of the radical, and I end up with 3x times the cube root of 2x, which is the same ultimate solution. So let's do a quick check of that. I want you to simplify the square root of 32x to the 7th. So I want you to try that one on your own. You can use either method. I'll show you both in just a second, but try it on your own. I'm going to go over it now. Method 1, method 2. So method 1, I recognize that 16 goes into 32. So I can say, if I'm trying, I'll rewrite this. So I have the square root of 32x to the 7th. I recognize that that's 16 times 2 times x squared times x squared times x squared times x. There's another way you can handle that, the exponents as well, that I can show you in class. But then I can rewrite this as 4 squared times 2 times x squared times x squared times x squared times x. And then I take the square root of those numbers. I end up with 4x cubed, because I take out 3 of those, times the square root of 2x. And that is my final answer. So I also could have written the exponents if you prefer. You could have written them as x cubed squared if you wanted to use your power rule there instead of writing these. You could have written x cubed squared and then taken that out instead. It's up to you how you want to imagine that working, or which one makes more intuitive sense to you. So for method 2, I'm taking the same values. I have 32x to the 7th. This time I'm doing my prime factorization, so I can break this into 8 times 4, 4 times 2, 2 times 2, so I have 2 times 2 times 2 times 2 times 2. So I make my prime factorization, and then I have 7 x's. And I'm circling, since it's a square root, the invisible index is always 2. So the invisible index is 2. So I circle 2 of a kind. So I end up with 2 times 2 times x times x times x times the square root of 2x stays underneath the radical. So that ends up being 4x cubed times the square root of 2x. And that is my solution, same as my other possible answer. So that's all for today. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.